Hi everyone, we'll be learning partial fraction decomposition, and my name's Arya Upadhyay, so let's get straight to it. So the objective for today is to find the original fractions that make up a rational expression. So here are some of the steps. First, factor the denominator. Completely factor the denominator into linear factors or quadratic factors that are irreducible over the real numbers. In other words, they have no common factors. Write a different constant numerator, a, b, c, over each linear factor. Multiply each fraction by the common denominator to clear out the denominator. Combine like terms and factor if needed on the right side of the equation. Make a system of equations by equating coefficients of like terms on opposite sides of the equation. Remember to hold empty spaces on the left with a zero. Solve the system for a, b, c, and then replace a, b, c in the numerators of the partial fractions in step 2. Then check your answer by doing the math on the partial fractions to make it into the combined fraction. Or what you can do is you can follow steps 1 to 3 and use the pick a smart choice for x method that I'll explain. And here are the steps for denominators of factors that are greater than power 1. The steps are the same until you set up the constants over the factors of the denominator. However, when you set up the numerator, it must be in a form that is 1 power less than the completely factored denominator. For example, over here you can see that we have 15 over x plus 1 squared and x squared plus 1. So I take a over x plus 1, then we take b over x plus 1 squared, then we have cx plus d over x squared plus 1. See that x squared plus 1 is factored into the lowest real form. A linear is in the numerator and a quadratic is in the denominator. Likewise, if the lowest common factor is in the denominator is a cubic, then the numerator would be set up as a quadratic form, ax squared plus bx plus c. The constant a is over the linear. Notice that when there are multiplicities of a factor in the denominator, the numerator will be set up as 1 power less than the factor inside the parentheses. So the best way to learn is by doing it. Go back to the video to see how I explained to do these questions. So what you need to do is set up the form of each partial fraction. You do not have to solve them, just set them up for now. I'll be showing you the answers on the next slide. Hopefully you pause the video and try to work out the questions by yourself. So here is how I solved them. First, you have x over x squared minus 14x. So what you need to do is factor the denominator, which equal to x over x multiplied by x minus 14. So what you need to do is take a over x, because that's one part of your denominator, plus b over x minus 14, and then you get x, so then you get 7 over x times x minus 14. Over here what I did is I took the denominator of x plus 3 and x plus 1, so that's when you factor out the quadratic equation. You take a over x plus 3 plus b over x plus 1, and then you equate it to the numerator over the denominator, which is x minus 2 over x plus 3 and x plus 1. Next, we have this cubic equation. We factor it out into x, x squared, and x minus 10. So we have a over x plus b over x squared plus c over x minus 10. Now from here, what we can do is we can take the numerator and put it over the denominator. Next, for number 4, x squared minus 3x plus 2 over 4x cubed plus 11x squared. So factor out the denominator, you get x, x squared, and 4x plus 11. Now what you can do is you can put it together, put the numerator over the denominator, and there we go. For 5, essentially you can take x minus 5 3 times because it's cubed. So a over x minus 5 plus b over x minus 5 squared plus c over x minus 5 cubed. And then you can put the numerator over the denominator. Then for number 6, you can take x plus 2 4 times. So that's a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed plus d over x plus 2 to the power of 4. So then what you can do is you can put the numerator on top of the denominator. So again, let's try solving these problems. Uh, the answers should simplify to a fraction minus a fraction, or a fraction plus minus a fraction plus minus another fraction. Hopefully you pause the video and you try to work out the questions by yourself. So here is how I solved these equations. So first what you need to do is you need to simplify the denominator again. So we took a over x plus 1 plus b over x minus 1. Then we were able to cross multiply, which was 1 equals to a x minus 1 and plus b multiplied by x plus 1. So we can take x as either 1 or negative 1. So you can take it as either or. So here I got b as 1 over 2 and a as negative 1 over 2. So then you can just go ahead and substitute in a and b. So the answer that I got is negative 1 over 2 times x plus 1 plus 1 over 2 times x minus 1. For number 8, same thing. You have to simplify the denominator, which gets you x and x plus 1. So you can put it as a over x plus b over x plus 1. Then you can just cross multiply, which gives you 1 equals to a times x plus 1 plus b and x. Then you can let x equals to 0 or x equals to negative 1. If you have a question on how we determined what x will be, you're essentially just taking x and you're equating it to whatever the portion equals to. So let's say that we have x plus 1. So what would it get to equal 0? So you're going to bring the 1 that to the other side, which would equate that x equals to negative 1. Correct? And then you're going to take x equals to 0. So over here, we just took x equals to 0. So going back to the equation, so we have x equals to 0, therefore a equals to 1. And where x equals to negative 1, we have a equals to negative b, where b equals negative 1. So then you can just go back into the previous equation and write down that 1 over x minus 1 over x plus 1 is the answer. For number 9, again, what we're going to do is simplify the denominator, which gets you x and x minus 3. So you can take it as a over x plus b over x minus 3, and then go ahead and cross multiply. So you have 3 equals to a times x minus 3 plus bx. So again, when you equate x to 0, you get that x equals to 0. And when you equate x minus 3 to 0, you get x equals to 3. So 3 equals to a times negative 3 gives you a equals to negative 1. And for the other side, when you equate 3 equals to 3b, you get b equals to 1. So therefore, when you substitute these back into the expression, you get negative 1 over x plus 1 over x minus 3. Then for number 10, we have the same thing. You simplify the denominator, which is going to give you x plus 3 and x minus 2. Again, cross multiply, which gives you 5 equals to a times x minus 2 plus b times x plus 3. So if you equate x minus 2 to 0, you get x equals to 2. And when you equate x plus 3 to 0, you get negative 3. So you have 5 equals to b 5, so b would equal 1, and then 5 equals to a times negative 5, where a would equal negative 1. Substituting these back into the original equation, that would give you negative 1 over x plus 3 plus 1 over x minus 2.